in this example, we've got g of x is x cubed, where x is any real number, okay? Now, let's go for it. Part A, we've got to state the values of g of minus 2, g of minus k plus 1, and g of k squared, just to get you used to the idea of substituting what's in here for what's in here, okay, in the formula itself, yeah? Alright, so part A, we've got g of minus 2 would be minus 2 all cubed, because instead of x here, we've got minus 2 here, okay? You get that, don't you? So that gets us minus 8. Alright, the second one was g of minus k plus 1 would simply be minus k plus 1 all cubed, yes, which you could write if you wanted to in that form, okay? But this is perfectly correct, yeah? Not wrong at all. For g of k squared, well then of course it's k squared cubed, because whatever is in the bracket gets substituted for x in the formula, doesn't it? Yeah? Okay, that would get us k to the 6th. Alright, not so hard at all. Part B, for what values of x does g of x equal x? Nice and simple. That's we're just going to substitute g of x equals x cubed. We get that, and all we've got to do is solve that for x, which is going to be nice and easy. Just going through the motions, we get x cubed minus x is naught, therefore taking out the common factor, x into x squared minus 1 is naught. Let's factorise this little beastie. There's a difference of 2 squares. Now we've got some nice linear factors, and we can use the null factor law to state that therefore x would have to be 0, 1 or minus 1, or put them in that order, and we'd be laughing, guys, wouldn't we? Now let's have a go at part C, D and E now on this screen. Part C, for what values of x does g of x, is it less than or equal to x? Alright, now those things are a little bit tricky, I find. I always like to draw a graph if I can, because it's a little bit hard to visualise, and a graph is a mathematical picture, and as you know, a picture is worth 1,000 words. So let's get 1,000 words on our side here. So what do we got? Let's have a look. This is y equals x, this straight line here. Here we've got this one here is y is x cubed. Now let's have a look. They intersect here and here and here, as we found in the previous question. Yeah, that's for when the two functions are equal. Now what I've got to find out is when is g of x less than or equal to x. Well, you can see it. You can see it from the graph. The y values. When are the y values of g of x less than or equal to the y values of x? So I'll just make it crystal clear for you. Have a look. Have you worked it out? Well, come on, I'm going to highlight it now. There she be. That's the first bit, see? And down there, right? Down there as well, yeah? So I've said here, g of x is less than or equal to x for x going from 0 to 1 inclusive, and also we have it happening when x goes from minus infinity to minus 1 inclusive, yeah? You agree with me? Yeah, beautiful, isn't it? So do a graph, it'll save your life, yeah? D, what is the image of minus 1? That's pretty easy. That's the y value pertaining to when x is minus 1, and it looks like it'll be minus 1. Great. And last but not least, the pre-image of 64. Now that was, remember, that was the pre-image is the x value, so this has to be the y value, okay? So I think we're looking at the cube root of 64. And that would be 4. Of course it would. Jolly good show. Over the screen we go, and we're going to have a look at a couple of CAS screens now to show you how to do these things from the previous example on CAS. Now we're using the TI CAS Inspire. You might be using something else, Casio or something else, that's fine. I'm just going to show you on this particular screen the TI Inspire. So you need to know how to do all these things very, very fluently, okay? So I've basically just defined x cubed as being f1 of x, and that's a done from the calculator. Then I've just put in f1 of minus 2, I got minus 8. I put f1 of minus k plus 1, I got that, yeah? Now, for this particular bit when we had to find out when g of x equaled x, I've said solve, that's on the TI Inspire, that's menu 3.1, which is menu algebra solve. So solve when f1 of x, as I've defined it, equals x, for x. That is the syntax you have to use on the Inspire. And you get this beautiful answer here. So what was this one again? Oh yeah, that was when it was less than or equal to x, and that's beautiful. Look at that. Came out very nicely. Very nicely. And last but not least, I've got here when f, that's just basically the image of when x is minus 1. Well, that was pretty nice, wasn't it? Let's have a look at something else. Oh yeah, now I just put this second dump on here. It's got the same sort of thing, except I've scrolled down a little bit, and this was the item which wasn't showing on this particular screen. That's the pre-image. So solve when f1 of x equals 64 for x, x equals 4. There she be. Pretty marvellous, huh? Get to use the calculator very fluently. It has to be like an extension of your brain. If it isn't, you're in a lot of trouble. Okay?